You could even print this out if you, whoops, what did I just do? I made it very confusing. You could even print these guys out, hello? If you want. There it is, right? And notice that the mean has gone down, but that's because there's more mass. The momentum might be the same. Yes? Is that beautiful? Yeah. That is a beautiful thing, right? So that's way number one to do it. This is probably the least accurate way to do it, but it's also probably the simplest way. Let me show you the second way to do it, and that's with the photo gates. This is what you do, I suppose, if you were an engineer and you were really going to worry about this. Okay, if you were going to try to get it right, I think this is what you'd do. Okay, so let me point this thing there, and what we've got is a photo gate, and I need to move these guys up. What I want is there's a little laser beam. It might not be a laser beam, it might be just an infrared LED that's going to shine at this. This thing on the top is called a flag. It's not the thing that we pledged allegiance to, as much as it's just something that's going to block these beams. Yeah? Okay. Like that. And what we want to do is we want this guy, we want this flag to go entirely through that beam, because can't we measure basically what we're going to know from this is we're going to know how long the gates were blocked, is what it's going to tell us. Okay? So if we know how long it takes this card to go through the gates, won't we know how fast it's going? Yeah? What? Yeah, we just need to know the length of the car. We measure that accurately, and we're pretty set, right? Okay. So what we want is this guy's got to go all the way through that, right? And then as shortly thereafter as we can, we want it to hit this second guy here, right? So I'm going to hold this guy right here, right? And then as shortly after the collision as possible, we want it to go through the second gate. Yeah? Kind of a thing. So it seems like, and this takes a little pre-planning, it seems like this is a good place for it, doesn't it? Yeah? Goes all the way through, hits it, then goes through that one. Okay, so I just have to remember that spot there. Oh, whoops. I've got to run the program. It's on this computer here. There we go. And then this is a weird thing. It's like, it's photo gates. So basically it's just sitting there looking at the digital states of those gates, and it's got a microsecond resolution timer. So it's like amazingly accurate, right? Okay. And all it does is just sit there and wait for the gates to switch one way or the other, right? And then it relays the time back to this. But then it's like, what does collection mean, right? Because for this thing, it like collects for 10 seconds and that's over, right? So what I did was I set it to collect for a minute. For a minute, it'll sit there and just record when the gates block and to unblock, right? So yeah, just be a little bit clever about that, because sometimes kids like click it and they think it's going to run forever. No, it only sits there for a minute looking at it. You can go into the thing and make it look at it for longer, but I think it doesn't take that much longer. So I'm clicking collect, and all that does is it makes that bar turn red. We have a minute now, which is kind of a lot of time. And here we go. And I think we got it. So let's save. I'm going to save this guy. Save as. Save it in the share folder. ComLab Photo Gates. There we go. Okay. Let me show you what that looks like. So let's we go. Continue without data collection. Oh, okay, there we go. Okay, so this is a little unclear here. What this means is that I believe one must be that the gate is blocked. Is that right? So it's a transition from unblocked to blocked, so one must be blocked, I'm just guessing, right? And then 0 is unblocked. So it was unblocked initially, and then it got blocked at 7.704414, yeah? And then it unblocked there. After the collision, it was blocked here and unblocked there. You know, what can we do with that? Well, we can copy that and run Excel and paste it in, because I don't think it really calculates here. Can't you figure out the time the time that it's blocked is equal to this guy minus this guy. Yeah? Okay, the time that this one is blocked is equal to this guy minus this guy. Yeah? Isn't that right? If you just subtract those values, that's how long it's blocked. Notice that the second time it was blocked, it blocked it for longer. What does that mean? It's going slower, yeah? Does that make sense? Okay, so we could figure out the velocity. The velocity would be simple. It would be like, how wide is that card? 5 centimeters, right? So 0.05 divided by this would be my velocity. You're going to probably want to measure it a little better than that than by looking at it and going, yeah, that's about 5. You know? Okay, so let me point the camera at the right thing here. Okay. That could be a really lame video. Sorry, it's never stopped me in the past. Okay. And there is a way, if you really want to, there is a way you can go down into Vernier software and you can actually have it calculate the velocity for you. You can go in there and tell it what the size of that gate is. And I've done it once, and it's not that hard, but it's not trivial. The reason why I didn't just pre-package it for you is that I think you're a little closer to your existence if you calculate it for yourself. So equals, again, it's going to be 5 centimeters, 0.05 divided by the time. Right. So there's the velocity. It was faster here, slower there, and then you could figure it out from there. Right. Ariel. Why does Ariel get all the attention? Oh, look at that. I didn't know that. Okay. So anyway, that's way number 2 that you can do this, is you can do the photo gates. That's probably the most accurate way. The uncertainty of this guy, though, for the photo gates, the uncertainty of time is vanishingly small. It's the smallest digit. And how many, where are we? This is tenths, hundredths, thousandths. It goes all the way down to, I believe we're accurate to a millionth of a second. So I think we can say that this is plus or minus 5 times 10 to the minus 7th seconds, right? So essentially you could just say that's 0 if you want to, or you can factor it in, right? Okay. The card, well, you're probably plus or minus a millimeter, aren't you, with the card? I'm guessing, right? So you're plus or minus 5 millimeters, measuring that. The mass, you're probably plus or minus 0.05 of a gram again, right? And so this is interesting. One thing generally, by the way, momentum's not conserved using the photo gates. Why do you suppose it's not? Yeah, there is air friction, right? It is slowing down, right? So some kids have actually messed with this, and I thought this was interesting. They actually tilted the track, and they tilted it until it took the same amount of time for the cart to go through the first gate as the second gate without any collision, which I thought that was an interesting thing to do. Isn't that interesting? So they basically tilted the track so that the air friction at that speed was negated by like a tilt in the track, which I thought was like, that's kind of an interesting thing. They got momentum to be a lot closer to be conserved. So anyway, that's the second way to do it. This is the photo gates way. And then let me show you the other way. And I think then the boredom in this classroom will be complete. Okay, we'll have people who are actually asleep and, okay. Let's make a new thing, save changes. Oh, okay, good. And then I haven't set this up, but we're going to have a little webcam that can take a video of a collision. Okay, and I think I'm going to go insert movie. Okay, so just open up this thing. You'll have a little station that will actually film a movie for you. Okay, and I can show you that. Let me show you this. Yeah.
For the videos, are like in Mythbusters where they have like those black and white bars behind the.
Yeah, we're going to do something like that, only not quite as good, probably. Oh, there we go. Found new hardware. All right. Okay, so I'm going to do this. I'm going to insert a video capture window. Okay, so with basically it'll just open up and there won't be any probes attached to it. We're just going to use the video for this. And this is what we do at Oaks Park, is that we have Physics 2 kids will be taking